All right, guys, let's get started. This is 11.7, 11.8. We're going to be dealing in worksheet number 8, which is called permutations or combinations. So again, how does the book separate this for your homework? For example, this is 11.7 and this is 11.8. Okay? Now, for figuring out how many possible outcomes are there, it is very similar to what we talked about before in the previous test that we've taken. And in fact, some of the questions required you to do some of the basic stuff that we needed to multiply. Okay? Okay, so guys, let's talk about a 4-digit ATM code. Who here has a 4-digit ATM code or some type of code you have to put to withdraw money? A few of you? Most of you? If you have an account? Okay, good. So, I bet that I could guess what your code is. Now, would I be able to guess it immediately? No. It will take me a while because we have 4 numbers, okay? And assuming that the numbers are any of the 10 digits that we have, so 0 through 9, and assuming that you could repeat the number, right? You're allowed to do that. For example, my 18, it repeats some number, so hopefully I didn't give that away. Don't try to figure it out, okay? All right. So, how many numbers do I have to choose from in the first digit? 10. How many numbers do I have to choose from the second one? 10 again. So we didn't put any restrictions. So basically, it's the counting principle. Remember that from the previous. So how many total possible codes are there that I would have to kind of go through to see if I could figure it out? I would have to stand at the ATM with your card, and I'm pretty sure after the 5th one, the cops would be there. But 10 times 10 times 10 is what, guys? 4 zeros, right?
10,000.
Yep. So 10,000 possible combinations. Okay. So thieves have, you see them in the movies, they have the little electronic devices that run through those. I mean, just like, so then they go, bing, okay, you got it. So the more numbers we put in the code, the longer it's going to take to get that code. Okay, that's why a lot of things require you to make a long password. Okay, it can't be short. It's too easy to come up with. All right. Okay. Now, what if we said, all right, now you can make up a code that does not repeat any numbers. Okay? Sort of like when we talked about without replacement, right? So let's see. Let's do the same 4-digit code. And this time, no repetition. Ugh. Which is very similar to the language of without replacement. Okay. See, guys, that affects your number. And this is sort of what happened on that back page of the test. Let me pause it. So the first one is going to be 10. But once I use up a number, I can't use up that number. So my next choice for the second digit is 1 less. So instead of 10 digits, I have 9. And then 8, and then 7. Okay, great. So what is 10 times 9 times 8 times 7? 5,040. You see that? We just cut the options in half. If there is a restriction for not repeating one number, then basically we just cut our options in half. We went from 10,000 options to 5,000 options, okay? Okay. So guys, there's actually a math symbol that does this little pattern that we see there. Obviously we know 10 times 10 times 10 times 10. There's a symbol for that. It's 10 to the 4th. But what about a symbol for, or a calculation, like a shortcut for 10 times 9 times 8 times 7? In other words, that number you start with minus 1, minus 1, minus 1. Anyone heard of that?
Is it the exclamation point?
Exclamation point.
Technical name, but
Yeah, it's called factorial, okay? So, we call it n, whatever number you're talking about, factorial. And that is basically n exclamation mark, just as she said there. So yeah. Okay? So that math symbol is telling you you're going to start with a number and then multiply the next number minus 1, like 9, and then minus 1 again. All right? So this is what we call a permutation. Okay? Okay, this is the summary of that. Okay, a permutation is basically order matters, and you cannot repeat stuff. Okay, this is without replacement. So permutation. So for this one, what if we did 10 factorial? Well, we would just multiply all these numbers here. Okay, how much is that? Every calculator is different, so really, I can't help you really fast because I have to study your calculator when I get to you. So just gonna have to look for it. You can search around. Maybe it's in a menu. I know for mine, this is a TI-30X. It's in a menu. It is not apparent right here. I have to click on PRB, which is probability, right? We're in the probability chapter. And then I see a P, a C, and then a exclamation mark. Actually, all three of these we're going to talk about today on my calculator. Permutations, combinations, and then now we're talking about factorial. So I just go click 10. Go get that exclamation mark if you can find it on your calculator somewhere. And it just avoids us having to type all the numbers in. That's all. Okay? What did you get? 3 million. Okay. Okay, great, guys. So this is just the introduction of what we're going to be doing and the symbols that we're about to see. Okay? Now, guys, let's compare the 10 factorial to our problem of the ATM code without repeating numbers. So I got 10987. Okay, so basically 10987 is the same thing except, a big chunk of it got chopped off. All right? Starting with the 6, 5, 4, 3, 2, 1, that went away. So how could we think about that and actually put that in a formula so that it will go away? So we can use the 10 factorial, but not the whole thing, just a portion of it. All right, and that's where the formula comes in. The permutation formula comes in to take our factorial, which is maybe really long, and start cutting out the part we don't want. So for example, we don't want 6, 5, 4, 3, 2, 1. We would just want 10 times 9 times 8 times 7, and that's it. So guys, I'm just trying to explain where this weird formula is going to come from. Okay, so just watch. So you know the factorial part. So this looks like this. P for permutation. Okay? But then there's a subscript N and R. Okay? And then it looks like this. N factorial. So if you think about our code example, 10 factorial. Okay, that's a lot of numbers. Okay? But how do we get rid of the 6, 5, 4, 3, 2, 1? We need to divide. We need to cancel out 6, 5, 4, 3, 2, 1. So how do we do that? Well, it looks like this. So you take the number you're working with and subtract, okay, how many ways this thing is being arranged. So for us, we have 10 digits to use, but we only have 4. It's a 4-digit code. So we're only allowed to use 4 of them. So out of all the whole 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, the R is telling us we only want 4. We only want 4 of those. So the formula that gives us just the 4 numbers, 10, 9, 8, 7, is going to be, you have to divide out the 6, 5, 4, 3, 2, 1. So that's what this little bottom part is, okay? So basically that's saying take the 10, subtract the 4, you're going to get the 6. And that 6 is going to cancel out everything appearing in the 10. All right, so watch. Where did I do that? So, okay, right here. So, for 10 factorial, guys, how can we, cancel out the 6, 5, 4, 3, 2, 1 so that we only calculate 10, 9, 8, and 7, okay? Unless you just know that you're supposed to do 10, 9, 9, 7, we have to have a mechanism, a formula to kind of produce that for us, okay? And that's why it looks weird, because we're dividing out the stuff we don't want, okay? So don't be afraid of this formula, okay? It's just trying to cancel out the stuff we don't want, all right? Now, guys, using the calculator, again, every calculator is different, but if it's scientific, you can find the P. You can find this P symbol, okay? So you have to look up your calculator's instructions. You can look up a quick PDF if you Google it. Google the title, comes up manual, and then click on the PDF. Either download it or just look at it right there, and then just look for the probability section and how to type this in your calculator. It'll save you some time. But it's not really that necessary. Like, oh my gosh, I can't survive without my calculator. Why? Because we can just do this. Okay, this is called the long way. All right, so this is a permutation. This is 5 items arranged 2 at a time. Only 2. So you put the 5 here, and then you subtract those 2 numbers and do the factorial of that one. That's going to divide out the part we don't want. Okay. So 5 minus 2 is 3. So again, this is why it works, because we do 5 times 4 times 3 times 2 times 1. Whoops. And then 3 times 2 times 1. So notice that all these numbers cancel out. And you're just left with 5 times 4. Which I hope you don't need your calculator for. Okay. All right. So let's do another one, and then actually no, go ahead and try number 3. Okay. Go ahead and try number 3. Don't look at the answers, please. Just try to work it out the long way. All right. So number 5, we're going to do a shortcut. I mean, besides your calculator, right? Your scientific calculator. So remember, guys, this is just saying, hey, 14 factorial. Only use 3. All right. That's it. That's all that's saying. So you need to do 14 times 13 times 12. That's it. It'll save you all this other stuff that's going on. Okay? Because the whole purpose of all this math is to take away this part that we don't want. Okay? We don't want that because we're choosing 3. Okay? So we don't want all the rest of it. So the math makes us do all that, but really you just do 14, 13, 12. That's it. You're done. Okay? So what is this? So 14 times 13 times 12 is 2,184, yes. Okay? Okay. All right. So, now for our next discussion. Our next discussion, that's basically 11.7. Yeah, question?
Yeah, because it's 3, would it count as crossing out? I'm confused on how you did do the 3, 2, 1, and...
I'm doing a shortcut. So I'm trying to avoid doing all that.
Oh, okay.
Yeah. Because in the end, when you do all that work, you're just going to have 3 numbers.
Okay.
14, 13, 12. We're just kind of anticipating just 3 numbers. Okay? This says use 3 of those 14 factorial numbers. 1, 2, 3. Okay? Boom, done. Okay? And if you don't like that, that's fine. You can just break it all out and then cancel everything out, circle what's left over. It's going to be the same thing. Okay? Okay, so that is 11.7. And so, combination. So, here's the thing, guys. Because this permutation formula has to do with order. It's an ordered arrangement. So, order, oh my goodness. Order matters. Order matters. Okay? Now, what if order didn't matter? Okay, this is without replacement and order matters. Combination is without replacement, but order doesn't matter. So if order doesn't matter, that means we're double counting. We're counting stuff, the same stuff, but in a different arrangement. Let's say flipped. So in the permutation, we're counting them as 2 different things. In combination, they're just 1. It's the same thing. Who cares about which order they're in? Okay, so combination order doesn't matter. Now, if order doesn't matter, then if we use this formula, we have too many. We're counting too many. We're going to have to cut it some more. So we have the factorial, cut out the part we don't want, but then we have to cut out the duplicates, or the ones that we are double counting. So now it has an extra piece to the formula. Okay, so combination formula looks very similar. Oops. So you have n factorial, and you have the same old n minus r factorial. But here's the additional piece. Okay, so remember, we still need that part to cut out the part we don't want. But we still need, now we need to cut out the duplicate, so we're going to do another r factorial. This, okay, cancels out. Duplicates, okay, duplicates. So I don't really have room up there. I'm going to have to go down here, which is fine. Okay, so number 2. Okay, a quick word about 0 factorial. It is not 0. Okay? Does anybody know what it is? It's 1. It's just something you have to remember. You can put it in your calculator. It'll tell you 1. Okay? So, for example, some calculators default with a 0 sitting there on the screen. So if you just do the whole 0 factorial, you're going to get 1. Just remember that. Because in number 2, the numbers are the same. So if you do the difference, it's going to be 0. Okay? So let's do it the long way for now. So this is just 6 factorial. And then we got to subtract, we got to divide out the difference of those two numbers. And then we have an extra 6 factorial right here. This one looks kind of weird. So again, 0 factorial is not going to be 0, so it's not going to be like undefined or something like that. It's just going to be 1. Okay? So if this is a 1, that means we are left with anything divided by itself, doesn't matter how weird it looks, it's still going to be 1. Okay? So this is where the 1 comes from. Now, think about the interpretation of this, though. 6 items, okay? And we're going to select 6 items from that 6, and order doesn't matter. Well, if you just pick all of them, that's just one option. Any other arrangement has everybody included, so it's like it's the same group in a different format. Order doesn't matter, so who cares? You can only do one option from that, okay? Let me pause this. Let's try another one here, number 4. Whoops. All right, so where do I put the 7? Top or bottom? Yep, top. And then we subtract the 2 from the previous formula to get the difference, but then we also have to divide out our duplicates, so that's going to be another 2 factorial, okay? So basically we have 5 factorial, 2 factorial down here. Now, could you put this in your calculator? Sure. If that bothers you, if it's annoying or whatever, that's fine. Just do it. Just expand it out. Okay. So I would rather use the bigger one, the 5, 4, 3, 2, 1, to cancel out all the 5, 4, 3, 2, 1 over here. And then we have a 7 and a 6 left, so the 1 is irrelevant. The 1 doesn't do anything to anybody. He's the nice guy. So 2, though, will divide the 6 in half. So basically, you can put this in your calculator, or you can just divide it in your head. That's 6 divided by 2 is 3. So you can do 7 times 3 as well and just get 21. Okay, so guys, the math is not complicated. You can still do this without a calculator. If your scientific calculator doesn't work, or you don't know how to use your calculator, whatever, you can still do it the long way. Okay. So why don't you guys try number 6, and then we're gonna work in groups to try to figure out, brainstorm the word problems. Okay, on the other page. So divide out the 3 and the 18. Make my number smaller. 2 and the 20. So now, all I have to do is, wait a second, don't I know 10 times 6?
Can you reverse?
Okay, so if you're trying to minimize all the numbers, you're trying to type in this thing, and all the numbers you're trying to write on your paper, and find some shortcuts, reductions. 60 times 19, that's all it is. Okay, question?
About last one.
Now, I want to hear from the question maker.
Oh, she had another question. What?
Okay, what happened? What do you mean, what?
20 over 17 and 3. Where does that 17 go? Because on the next one it's 3 times 2. So that's
17 took away all the ones that were here. Pretty long, so I said, I'm not going to write them. You can if you want. The 17 takes away the first 17 numbers. So why write it? If some of these disappear. Leaves you with the first 3, right? And we could have seen that from here. Use the first 3, that's what this is saying, of the 20 factorial. Okay? You're more than welcome to do it the longer way if you want. It doesn't matter. Okay? Do it however you understand. As long as you get 1140 at the end, I'm okay with that. Okay? Okay, other questions about the 1140? Oh my goodness, it's pitch black. That was definitely thunder. Okay. So, guys, I want to be clear on the difference in the formulas, why they look weird. They're trying to cancel out stuff you don't need, and the combination has an extra piece. So they're almost the same. The combination has an extra number right here that cancels out the duplicates of rearranging the same stuff So it'll take care of that problem. Okay. So now, so obviously if you divide more out, the number's going to be smaller. Okay. The less you take out of the factorial number, the bigger the number is going to be. Okay. Just like over here. 10 factorial, well, that's 3 million. If we take some out, obviously it's going to be less. Okay? So that's why we have smaller numbers for the combinations. All right? So now I want you guys to take a look at the next page.
I have a question.
Yes.
So number 7 is 8.
Yeah.
How do we, it's just 6 factorial and 3 factorial?
That's just all the numbers. No cancellations at all. So that's just use all the numbers. 6, 5, 4, 3, 2, 1. Okay. Remember, the formulas is not going to use the whole thing. The formula is there to take out some of the stuff. If it's just a plain factorial, then use every number. Okay. Okay. So in the word problems, this is all mixed up. Okay. Try not to look at the answers. The way you're going to determine permutation versus combination is you're going to ask yourself, does order matter? Okay? Will the order affect what's happening? If it doesn't matter, according to the context, it's combination. If it matters, okay? For example, choosing a president, vice president, and treasurer of a club, order matters. Once you fill up the president spot, you cannot rearrange that. You cannot switch places. It's just that's the way it has to be. That's permutation. Okay? If you're eating food and it doesn't matter what order you want to do the arrangement, then it's fine. It's not going to affect anything. Okay? So guys, what I want you to do is spend some time thinking about, does order matter? And then figure out which of these you're going to use. Okay? So for example, number 9. It says, a photographer... I'm sorry, you had a question?
I said, how do you know which is which combination or
If order matters or not. So we're going to see some in a minute. Yeah.
How do we tell like?
Okay. Well, that's why you have to read it. You have to read it and figure out. Okay. Okay. So this is using common sense, guys. Okay. So a photographer wants to arrange 3 children in a row for a family photograph. In how many ways can this be done? Okay. Does the order matter for each picture? Yeah, it does. You can only put the oldest person here, the second oldest here, and the third oldest here. Or, that's one picture. A different picture would be the youngest first, then the middle age, and then... So, if you change the order, those are 2 different pictures. Okay? If you change the order, those are 2 different pictures for the family photograph. It's not the same picture. You see what I'm saying? So, order matters here. So, you're going to have to use permutation. Okay?
So, when this is like in a row, it means like in order of age. Is that what you're saying?
It
So
just
it'd be
whatever.
like 6.
That was just
Okay.
an example, but it depends on. I mean, most families do it by age, so it looks like a little slope, right? Unless you're triplets and then you're all the same size or whatever. Okay. Yeah, that's true. So guys, Does it matter? Does order matter? Yes. Okay, order matters. Okay. So if order matters, then you're going to use permutation. Okay. Straight factorial. See, this is unnecessary, but this is if you're using the formula literally and okay. So we don't need to do that because we're using up all the children. We're not going to take one of the children out and have, how many ways can you do 2 out of the 3? We're not doing that. Since we're using all 3, this formula is unnecessary because it's just, that's the definition of factorial, okay? All right, so go ahead and discuss what you think. You know, this is kind of, you have to make a decision and then do the calculation, all right? Discuss this for the rest of these here. And then I'm going to pick a few for your turn-in today, okay? So let me give you a few minutes to work on that. Actually, time is up. So I want to go ahead and pass out the tests, okay? So we're going to do this next time. All right, we'll do this next time.